All right, so in 2-4, we talked about complex numbers, right? And we treat, well, I specifically is the imaginary number that represents the square root of -1. So in things like adding, subtracting, multiplying, dividing, we treat I as though it's a variable when we combine like terms and that kind of stuff. But anytime I is raised to a higher power than 1, so if it's squared or anything higher, then we replace it with that -1. So that's that's how I behaves differently. So when you see, first of all, the instructions say simplify, and on the test it will also say put answer in standard form. And that means the I comes last. So it's A plus BI is standard form. The I, or the term with the I, will come second. So with something like number 1, you can simply just take that 9i and distribute it. So 9i times 5 is 45i. 9i times -3i is -27i squared. And then you never want to leave I to a higher power than 1 in your answer. You're going to immediately grab that I squared, replace it with a -1, and then I get 45i plus 27, and I rearrange it so that the I comes last, so it'd be 27 plus 45i. Questions on that one? Okay, then we go to 2, and what do you have to do first? Take that negative out, make it an I on the front. You can't do anything with your square roots until you do that. So I'm going to take the I's out here. Sounds violent, but I'm taking the I out. Plus 3i squared 45. Then I want to break down your radical, okay, by using your factor tree. So 20 would be like 2 and 10, or 2 and 5, or 2i square root 5. Plus, take that 45, break it apart. So it could be 5 and 9, which is 3 and 3. And the 3 comes out. 3 times 3 is 9i square root 5. And then only because they both have an I and both have a square root 5 can I combine these into 1. I'd add that 2i and the 9i. I get 11i square root 5. I'm okay with you leaving it like that. You could also rearrange it so that the I comes last. You just have to be careful and make sure the I does not go underneath the square root. So I would have taken either of those answers. Questions on that one? Okay, 3. Now I've got an I in the denominator. In the numerator, it would have been fine, but in the denominator, this is saying you have the square root of a negative number in the denominator, which is irrational, so we can't leave it. We multiply both the top and the bottom by the conjugate of the bottom. So I'm going to multiply by 5 plus I in both the top and the bottom. In the numerator, I can either FOIL that or I can use my special product, because that would be 5 plus I squared. But if we FOIL it out, we'd get 25 plus 5i plus 5i plus I squared, or 25 plus 10i and I squared becomes -1. And I get 24 plus 10i in my numerator. With me so far? Okay, in the denominator, there's a shortcut when we multiply a complex number by its conjugate. It is a squared plus b squared. The a is the term without the I, so it would be 5 squared. And the b is what's on front of the I, so it would be 1 squared. So I get 25 plus 1, or 26. And then if they are all divisible by the same number, in this case they're all divisible by 2, then we reduce. This would be 12, 5, 13. And you can either leave it as 12 plus 5i over 13, or you could separate it out, 12 over 13 plus 5 over 13i. Either of those answers will get you full credit. But you do have to simplify it. Questions on that one? All right, then the last one, we are solving, okay? The first thing I would do is check to see if it was factorable. So I would multiply first times last and see if there's a product or two numbers that when multiplied together give you that number but add up to -4. It's not going to happen. So instead, we're going to use the quadratic formula. Negative b plus and minus the square root of b squared minus 4 times ac all over 2 times a. And a is 16, and b is -4, and c is 3. So I get -4 plus and minus the square root of b squared minus 4 times a times c all over 2 times a. And I get +4 plus and minus the square root of 16. This would be 12, 16 times 12. Minus 192 over 32. And then 192 minus 16 is -76. Over 32. Yeah. Oh, yeah, I forgot the 1. Thank you. -176. And then the I comes out, so I bring the negative out front. 4 plus and minus I, square root 176 over 32. And then we break down that 176. So I know 2 goes in here. It'd be 88 times. And then that's 2 and 44, and 2 and 22, and 2 and 11. And for each pair of 2's, 1 goes to the front. So I have 1 pair of 2's, I'm bringing a 2 out front. Another pair of 2's, I'm going to bring that 2 out front as well, and then the 11 stays underneath. So I get 4 plus and minus 4i square root 11 over 32. And then I see if I can reduce it. The same number goes into 4, 4 and 32. It'd be 1, 1, and 8. And I'd get 1 plus and minus I square root 11 over 8. Or 1/8 plus and minus square root 11 over 8i. Again, either of those will get you full credit, but it has to get reduced. Questions?
If it was factorable, could you still use the quadratic?
Yeah. Anything that's squared, you can use the quadratic on. So you can always use the quadratic. Obviously, it's not always factorable. There will be one time on your test in which it is not factorable, and it will force you to use quadratic. But then there's going to be other times when it's factorable. But you can always use quadratic as long as it's a squared. Questions on I's before we move into the next section? So the next section kind of pulls back the last 2. It puts 2, 3 together with 2, 4. So the good news is it's review, okay? It just includes now the imaginary numbers. All right, so 2.5 is called the fundamental theorem of algebra. Again, last section that's on your test on Thursday. We start with the linear factorization theorem, which says if f of x is a polynomial of degree n, then where n is greater than 0, then f of x has precisely n number of roots. In plain English, the highest exponent is equal to the total number of roots. So if I have x to the 7th plus or minus something, 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 and that's the highest exponent, then there would be 7 roots. Those roots can include real numbers, non-real numbers, rational numbers, irrational numbers. But in total, even repeated answers, but in total, there needs to be that 7 or whatever the degree is. So when you look at this, this is something that's written out as its linear factors. Okay, this thing has 1, 2, 3, 4, 5, 6 linear factors. And it's just showing you that all of these types of answers might be roots. So you might get positive or negative real numbers. You might get fractions or decimals. You might get irrational numbers, positive and negative. You might get imaginary numbers. And if you have one imaginary number, you have to have another because they come in pairs. So example 1 just says find the exact number of zeros. We don't need to find them yet, but how many are there? 3. Same as the highest exponent. Don't fall for it always being the first term because it may not be. It's just the highest. Okay, example 2 now says solve the function. So the first thing I'm going to do is figure out how many answers should there be. For A, there should be how many? 2, okay? Then I would say try to factor next. Can I factor x squared plus 36? No. There is something of 2 squares, but what's it called? The difference of 2 squares. There would have to be a minus there, okay? So if it doesn't factor, now I've got other options. I could do the quadratic formula because this is quadratic, right? Or I could try to set it equal to 0 and isolate the x squared. So now I would subtract the 36. And then I would square root both sides, making sure I put a plus and minus in front of that negative 36. And I would get x equals plus and minus the square root of negative 36, which is what? 6i. Good. And 1 is positive and 1 is negative. So there are my 2 zeros. Then I go to B. How many answers are there? 3. Can I use the quadratic on this? Why not? It's not squared. Highest exponent has to be second in order to do quadratic, okay? I can take out an x, and I get x squared plus 25. Now I could do the quadratic on that second term, so I could take out the x and then use the quadratic, or I could see if that's factorable. It's not, which means I'm going to split and solve here. So I get x equals 0. That's one of my answers. X squared equals negative 25. And x equals plus and minus the square root of negative 25, which is 5i. Now 3 answers. Negative 5i, positive 5i, and 0. If you're writing this as like an open-ended question, you can totally leave it as plus and minus 5i, okay? If you're doing it on WebAssign and it says like the smallest, the next, whatever, obviously then you need to separate it out. If neither of those are happening, I don't care what order it goes in. Unless it indicates specifically to put it in a specific order, you can just list them. Still good? All right, example 3. Find all the zeros of the function and then write the polynomial as a product of their linear factors. So first thing we're going to do is find the factors. How many should there be for A? 2. Is this factorable? Are there factors of 1 that sum to negative 3? Nope. Okay, I can't isolate the x. Like I can't set it equal to 0, move the 1s. Like you can't isolate it because there's 2x. There's an x squared and an x, which means you have to do what? Quadratic formula. A is 1. B is negative 3. C is 1. And I get negative b, which is negative 3, plus and minus the square root of negative 3 squared minus 4 times a times c all over 2 times a. And I get 3 plus and minus the square root of 9 minus 4 over 2. 3 plus and minus the square root of 5 over 2. Because we're going to write this as a product of linear factors, I'm going to separate these out. This is really 3 minus root 5 over 2 and 3 plus root 5 over 2. So if it had just asked me to find the zeros, I'd be done. But then it asked me to write them as a product of linear factors, which means I have to put it behind x. So it would be x minus 3 minus root 5 over 2. and x minus 3 plus root 5 over 2. Now I still have to do two things. One, distribute my negative. Two, get rid of the over 2. You cannot leave a fraction in your product of linear factors. So to get rid of that 2, I'm actually just going to multiply it by the x. So I end up with 2x. And now I'm going to distribute this negative to both of these. Minus 3 plus root 5. And then 2x minus 3 minus root 5. And this is how you write it as a product of linear factors. So you can't have any fractions. You just multiply the variable by whatever's in the bottom to get rid of that fraction. And no parentheses should be in there. So we're going to distribute that minus to both those terms. And then let's say we had extra time. You could actually FOIL this back out. And when you FOIL it back out, you should get your question. Do I think you'll have a ton of extra time? Probably not. But if you did, you could FOIL it back out to get your question. Yeah.
I'm confused after this part. When you put 3 plus or minus square root of 5 over 2, why do you do that?
Because, you mean this one?
Yeah, after that.
After that, you have, so because, if it just said solve, like find all the zeros, then you'd be done. I would just do 3 plus or minus root 5 over 2. Those are my zeros. But then because it says to write it as a polynomial product of linear factors, you have to write it behind the x. So x minus whatever those answers are. And for that, you'd have to separate them out. And then you have to get rid of your fraction. And then you have to distribute your minus. All right, go to B. So I'm going to same thing. Now I want to factor it. If I can I factor 16x to the 4th minus 81? Are they both perfect squares? Yeah. Yes. Is there a minus between them? Yeah. So I'm going to factor this by using the different two squares. Square root the 16x to the 4th, and I get 4x squared. It goes in that first spot in either one. Square root the 81, I get 9. And then 1 gets a plus and 1 gets a minus. Can I keep factoring? Not the first one, right? The first one is now the sum of two squares. I can't factor that. But the second one, I can. This is another sum of two, difference of two squares. So this would be 2x plus 3 and 2x minus 3. Now I'm going to split and solve them. So I'd subtract the 9. I get negative 9 equals 4x squared. Divide by 4. X squared equals negative 9/4. Square root both sides, putting the plus and minus on the front. And I get x equals plus and minus the square root of 9 over 4 is 3 halves, and there's a negative in there. So it's 3 halves I. So there's two zeros there. Negative 3 halves I and positive 3 halves I. Remember, i's always come in pairs. Then I do 2x plus 3 equals 0, so that's negative 3 halves, and 2x minus 3 equals 0, positive 3 halves. So my 4 zeros are those. Negative 3 over 2i, positive 3 over 2i, negative 3 over 2, positive 3 over 2. And there's 4 of them, right? Highest exponent was 4 to begin with. Now I got to write them in terms of linear factors. So I get x minus a negative 3 halves I, x minus a positive 3 halves I, x minus a negative 3 halves, and x minus a positive 3 halves. And I got to get rid of my denominators, and I got to get rid of my parentheses. So this 2 comes over here. This becomes 2x minus a negative becomes plus 3i This 2 comes over here, 2x minus 3i. 2 comes over here, minus a negative becomes positive, 2x plus 3. 2 comes over here, 2x minus 3. And there's my product of linear factors. Now we almost got here, up here, when we factored it out. But if I had left that as a product of linear factors, what's wrong with that? Is something that's squared linear? No. So this was my problem. That 4x squared could not have stayed that way because that would not have been a linear factor. Still good? Yes? All right. Just add a lot of words now. Find all the possible zeros of the function. So we're pulling back to 3. Find the actual roots. Write the polynomial as a product of linear factors. Use the factorization to determine the x-intercepts of the graph. And then use a graphing utility to verify that the zeros are the only x-intercepts. So start with possible zeros, okay? How do I figure out the possible zeros? Plus and minus, last over first. Not the possible number of them, but the actual possible roots is what it's looking for. So what are the factors of the last term? What are the factors of 16? 1 and 16. 2 and 8. And then 4 and 4, right? And on the front, it's just a 1. So I put plus and minus 1, 2, 4, 8, 16. That's my possible roots. You with me so far? Now I got to find my actual roots, okay? This is where, again, we're going back to 2, 3, where we have to test these roots using synthetic division. So first thing I would do is see if any of the Descartes rule helps you, right? How many sign changes are in my original? 1, 2, 3, 4, right? So there's 4 or 2 or 0. If that was a possible of like, let's say there was 1, then 100% sure there's going to be a positive answer. I would have worked on my positive answers. If I make it negative, the negative x to the 4th, it's going to go back to positive. The negative x to the 3rd here is going to change, so this becomes positive 4x to the 3rd. The negative x squared would stay positive. The negative x here would make that positive 16x, and then it's plus 16. How many sign changes are there now?
3, 2.
Nope. Look at, I know it kind of wrote messy, but this is my updated polynomial.
Why didn't the last number get switched also?
Because there's no variable on it.
Oh.
Yep. How many sign changes are there? 0, which means there's no negative roots. So I'm not going to try a single negative. Does that make sense? That's how Descartes' rule helps you. So I'm going to start with 1. I'm going to put 1 on the outside. And I'm going to do 1, negative 4, 8, negative 16, 16. Bring down the 1. Doesn't work. Go to 2. And that one works. So 2 is one of my zeros. And what's remaining, this would be my remainder. This gets the x squared, and the x to the 3rd. So I got x to the 3rd plus x squared. Sorry, minus 2x squared. 2x squared plus 4x minus 8. Now, I can't use quadratic yet, but there are 4 terms. Is there a way to factor if there's 4 terms? Group them. Let's just see if it factors. If it doesn't, I'd have to keep trying my zeros. So x squared comes out, and I get x minus 2. Positive 4 comes out and I get x minus 2. X minus 2, x squared plus 4. So it does factor. Now I split and solve, and I get x equals 2 again. I'd get x squared equals negative 4. X equals plus and minus the square root of negative 4, which is plus and minus 2i. And those are my third and fourth zeros. So step 1 was find the possibles. We did that. Step 2, find the actuals. Step 3, write the polynomial as a product of linear factors. So I have x minus 2. I have x minus 2 again because 2 happened twice. X minus 2i and x plus 2i. This is your linear factors. Then it said, use the factorization to determine the x-intercepts of the graph of this function. What do you think are going to be the x-intercepts of this function? The real ones, which in this case is just 2. If I graph it, and what's the multiplicity on 2? It's going to bounce at 2. That's what I expect it to look like, right? So get out your graphing utilities. All right, so I graphed it on my graphing utility. So I'll be honest, on a question like this on your test, you would not have the graphing utility. If it asked you for the linear factors and it's factorable, you'd be able to do it without it, okay? But I know it confirms for me that there's only one real zero and that it has a multiplicity that's at least even, which means 2. It could have been 2 or 4, but we had it twice because it bounced there. Questions? Okay. Now let's talk about conjugate pairs. I said it already, okay? But i's come in pairs. So for every I you have, its opposite also has to be an answer. So whether that I is a single term, like 2i, or it's an expression like 2 plus 3i, its conjugate, which means the same numbers but the opposite sign on the imaginary part, would also be a 0. So if I told you 3i was a 0 of a function, you automatically know negative 3i is a 0 as well. If I told you 5 minus 7i was one of the answers, then 5 plus 7i also has to be an answer, okay? Imaginaries come in pairs. So example 5 says, find a polynomial function with the real coefficients that has the given zeros. So we're working backwards like we did this at the end of 2-2, where if I gave you numbers, right, we did x minus this and x minus this and we FOILed them out. It's the same concept, but now we're pulling in the i's. So if I look at A, it gives you 3 is a 0. It gives you 3 plus I is a 0. What else is a 0? 3 minus I. You have to know to add it on. Then I do x minus whatever's there. So x minus 3, x minus 3 plus I, x minus 3 minus I. As long as you remember to distribute that negative, you don't have to do that step and then this step, but be really careful with your signs. The sign on the real part, which in this case was a 3, should be the same. The sign on the imaginary part, which in this case is the I, is the one that should change. Now, like we did in 2-2 with the square roots, I would multiply those out first, because if you do it correctly, your i's will go away. So I would get x squared minus 3x plus xi minus 3x plus 9 minus 3i minus ix plus 3i minus I squared.
Do you have to multiply all of that by x minus 3 too?
Yep. Well, here we cancel, right? Everything that has an I should cancel in this step. Xi and negative xi cancel out. Negative 3i and positive 3i cancel out. And I squared becomes negative 1. So this becomes minus a negative 1 or plus 1. So I get x squared minus 6x plus 10 times x minus 3. And then we FOIL that out, or multiply it out. X to the third minus 6x squared plus 10x minus 3x squared plus 18x minus 30. And combine your like terms. So I would just say be so very careful. And always multiply these out first. I don't know why you would want to do it the other way, but people don't listen and then they try to do the first two on the test and it gets super messy. Always go with the eyes first because if you do that part right, the eyes will cancel out. All right, we're just going to set up B. We won't work all the way through it just for time purposes, but we'll set it up. So what's the missing part? 5 plus 3i. So it would be x minus a negative 2 means this would be x plus 2. X minus 5 plus 3i if we distribute the sign. And x minus 5 minus 3i. So again, notice the sign that's different is the one that's on the I term. The 5 or the real part still gets the same number. And then I would FOIL out the second one, and then I would take that product and multiply it times the first one. Are you okay on the process from here? Like, am I okay not to work that all the way out? Okay. All right. Now we go a step further on that one. Use a complex zero to find the remaining zeros. So in these questions, it's going to say, here's your big polynomial. One of the roots is blank, okay? And it will be an imaginary root. Find the remaining. So you're going to find the additional one, which will be the complex conjugate. If I said that 5i was a root, I would add on negative 5i. Then we're going to FOIL out the roots that are given. You'll have 2. Your i's will cancel out. And then you're going to divide the original function by your new quadratic expression, and you will get the remaining 0. I will tell you, this is not a fun process, but if you practice the steps, it's the same steps every time. This is something you can definitely get the hang of, okay? So it will look like this. Use the given 0 to find all the zeros of the function. So I have my big function, 2x to the third plus 3x squared plus 50x plus 75, and my 0 is 5i. As soon as you see 5i, you add on. Negative 5i is my other 0. Then I'm going to find that expanded form of those linear factors. So x minus 5i times x plus 5i. You could FOIL that out, or it's a special product. I square the first term. This is a squared plus b squared plus 25. If you FOIL it out, you get a negative 5ix and a positive 5ix and then a negative 25i squared, which goes back to positive 25. But because it's the product of complex conjugates, you can just do a squared plus b squared. Now I have to take this and divide it by what I just found. Can I use synthetic division? When can you use synthetic division? It has to be x plus or minus something. It cannot be squared. So we can't use synthetic division. So remember I said we're going to review every topic that we've learned up to this point in chapter 2. This is where long division gets reviewed. So then I'm going to take that x squared. I'm missing my 0x plus 25 and divide it into 2x to the third plus 3x squared plus 50x plus 75. Yeah. So they won't all be able to be factored by grouping. Okay. Yes, because from there you can take out the x squared plus 25. But on your test, it won't be able intentionally. Yep. Okay, so I go first and a first. What do I have to multiply x squared by to get to 2x to the third? 2x. Multiply it times both. So 2x to the third plus 0x squared plus 50x. Change your signs and add. Cancels. 3x squared cancels. So this is a 0x. And I bring down the 75. You even need your placeholders when you're working through. Now, what do I have to multiply x squared by to get to 3x squared? Positive 3. Multiply it times all three. 3x squared plus 0x plus 75. Change your signs. Cancels, cancels, cancels as it should because x squared is plus 25 we said was a factor. So then this is my remaining factor. And when I set that equal to 0, I get my remaining 0. So because it says use the given zeros to find all the zeros, I would list the one they gave me, the one I added on, and the one I just found. All right, last one. Use the given zero to find all the zeros of the function. Take a deep breath. This one does not feel good, okay? Because now I have a binomial, right? So if it's 5 plus 2i, what's my other one? 5 minus 2i. So when I want to expand and FOIL this, I have to do x minus 5 minus 2i and x minus 5 plus 2i. Now I FOIL it out. X squared minus 5x plus 2ix minus 5x plus 25 minus 10i minus 2ix plus 10i minus 4i squared. If you've done it right, the I should cancel out. So a positive 2ix, a negative 2ix, a negative 10i, a positive 10i, and then I squared becomes negative 1, so this becomes positive 4. And I get x squared minus 10x plus 29. Now I have to divide the original by what I just found. So x squared minus 10x plus 29 goes on the outside. X to the third minus 7x squared minus x plus 87 goes underneath. So it would be something like that where it's not factorable. And x squared into x to the third is x. I'd get x to the third minus 10x squared plus 29x. Change your signs. Cancels. 3x squared minus 30x plus 87. And now it's x squared into 3x squared, so it's a positive 3. 3x squared minus 30x plus 87. Change your signs. Cancels out, which it should. And my remaining factor is x plus 3, which means my remaining 0 is negative 3. Questions? It's just like a lot of tediousness stuff, okay? I get it. Just make sure you're really careful with your signs. People make some weird mistakes on their signs, okay? And again, that's where the content cuts for your test. So tomorrow and Wednesday, we'll review for your test. But the good part about, the good thing about 2-5 is that we just practice long division, right? We practice synthetic division. We practice finding the conjugates. We've practiced multiplying out the conjugates. Like all those things that you already had in the earlier sections came back in this one. So you're kind of being forced to review while we do it.